Vectors. So we are starting with vectors, right? So what are vectors? Anybody is having any idea about it? Karen, you have any idea about what are vectors?
No, not the definition.
Not the definition. Okay. Any one of you? So vectors are physical quantities which have both magnitude and direction, right? So by physical quantities, I mean that they should have unit. Obviously, when there is a physical quantity, it should have unit. So you can say that physical quantities are those quantities which have unit, right? So any physical quantity which have both magnitude and direction are called vectors. Okay. So examples are examples of vectors are velocity, displacement, force, acceleration, and there are many, right? There are many vectors. So how do we represent a vector? A vector is represented by, so representation, there are two types of representation. First one is symbolic representation. So symbolic representation is like we can represent it with an English alphabet with an arrowhead over it, right? So it can be A, it can be B, it can be R, it can be caps may, it can be A, right? So it can be an English alphabet with an arrowhead over it. So simply write an English alphabet and put an arrowhead over it. You are representing a vector, right? Then comes the geometrical representation. Okay. So geometrical representation is we denote. So if this is the XY plane, I'm just trying to draw the vector in the XY plane. So this is our XY plane. And here we have a vector like this, right? So it's a line. This is called the tail of the vector. This is the tail of the vector, right? This is the head of the vector. Okay. The vector, as I said, it can be represented by an English alphabet with an arrowhead over it, right? But the magnitude of, so this is how it is represented in geometrical representation. But the direction of this vector is shown from, can be shown from, or it can be represented from positive x-axis in anti-clockwise sense, or you can mention the direction also. So this is the direction of the vector, right? Theta, angle theta is the direction of the vector, and the length of the vector is its magnitude, which is given as like, which is represented like this. The length of the vector is the magnitude of the vector, and it is represented like this. Any challenges, any queries till this point? Any one of you? You have to say yes or no. If you have understood it, say no. If you don't have any queries, just mention no queries.
No, sir.
No queries. Okay. So now, how do we represent? How do we represent the magnitude of a vector? Magnitude of a vector. How do we represent? So I have a vector like this. I have some vector r, let's say, okay? So magnitude of this vector is represented by an absolute value sign, right? Two parallel pipes here. So this is how it is written. So this indicates the length of the vector, right? So you measure the length, that is the magnitude of it. Obviously, you have to draw it by the scale. So that is how you can draw the vector. Any challenges? Any doubts? Direction समझ में आया बेटा? Direction, magnitude. I hope all of you understood this. Right. So this is magnitude of the vector. Now the next part is, what is a position vector? So position vector is a vector which represents the position of a particle with respect to a reference point. So a vector which represents the position of a particle with respect to a reference point is called as position vector of the particle. Okay. A vector which represents the position of a particle with respect to a reference point is called as a position vector. So for example, I'll just show you how to draw a position vector. Suppose this is our xy plane. Please pay attention, all of you. This is our xy plane. This is x-axis. This is y-axis, right? This is origin. So we have a point A, we have a point B here. So my question is, if I want to find position vector of A if I want to draw position vector of A with respect to O, if I want to draw position vector of A with respect to O, how do I draw it? I join these 2 points. I join these 2 points. The head of the vector will be pointing towards A. The tail of the vector will be at O. So what is this vector? This vector is position vector of A. So I am using an English alphabet R to represent the position of A with respect to O. This is how we write it. So what does it mean? RAO? It means it is position vector of A with respect to O. So O is the reference point here. O is the reference point and A is the particle of which we want to denote the position. Understood, all of you? So the tail of the vector, will be at, the tail of the vector will be at reference point, that is O in this case, and the head of the vector will be pointing towards A. I hope this is clear to all of you. Yes or no?
Yes.
Okay. Now, any one of you who can answer how to write position vector of B with respect to O? Any one of you? Are? Ha, yes. Please go ahead.
You would draw a line from O to B, pointing towards B.
Yes, very good. The
Then
tail
it
of
would
the tail will be at
B.
O.
No, sorry.
ठीक है? And how do we write it? How do we symbolic representation will be R vector?
B with respect to O.
Very good. It's RBO. I hope all of you understood this. Yes or no?
Yes.
So we have Bhavani, Harshita, Haran, and Siddharth. Right? Okay. So RBO, RAO. Now, RBA. So Siddharth, please switch on your camera. Siddharth. ओके सॉरी, सिद्धार्थ नहीं है ये, रितेश बिस्वाल। रितेश, yes Ritesh,
Yes,
how
sir.
do we draw this vector? Acha,
Uh,
first of all tell me what is this vector, how do we elaborate this vector? It is
this is a
representing,
projection vector
okay, of
of B with
B,
respect
okay,
to A.
very good. B with respect to A. So how do we draw this vector, Ritesh?
The tail will be at point B, the head will be at point A.
Very good. So tail will be at point B and the head will be at point A. So this is how we represent position vector of, sorry, ulta hai bataya. Head will be at B and tail will be at A. So this is position vector of B with respect to A. I hope all of you understood this. Yes or no? So if you have understood it, please copy this quickly. Okay. And once you are done making notes, please type done in the comment. Yes, I'll share the recording, Bhavan. Please make notes and please do it quickly. Huh? Obviously, I'll share the recordings. You can go, you can revisit it and make your notes later on also. But please try to do it right now in the time given. Once you have noted, please type done in the comment window and please be quick. Huh? Time बेटा थोड़ा कम लगाना चाहिए आपको. हाँ? चलो. I hope all of you are done with this. Noted? Bhavani, Harshita, Ritesh. चलो. So this was position vector. Okay. Now let's learn about addition of vectors. ठीक है? So vector addition follows a different law. It is different than our scalar addition. ठीक है. In scalars, what were we doing? अभी तक जो आप करते थे, till now what you are doing was you are trying to add two simple numbers. 2 plus 3 becomes 5. In this case, it doesn't happen like this. When two vectors are added, there are two vectors A and B, and when these two vectors are added, we get a vector only, and the process of adding these two vectors is different. So, but please remember, there is this statement which you should always remember before moving ahead into addition of vectors. So the statement is, a vector never changes इसको never की जगह लिख दो, a vector does not change if it is moved parallel to itself. A vector does not change if it is moved parallel to itself. This is what is very important to understand addition of vectors. So this is a vector. This is a vector. When you move it parallel to itself, is the direction changing? No. Is the magnitude of the vector changing? No. So always remember, a vector does not change if it is moved parallel to itself. I hope I am clear to all of you. Yes or no? Now I have two vectors, A and vector B. And let's say these are the two vectors which we have. This is vector A, and we have these two, this vector, which is vector B, right? Now, to add two vectors, what we do is we keep one of the vectors fixed. We fix one of the vectors and we call that as reference vector. So in this case, I am taking A as the reference vector, right? So I am fixing A and I am moving B parallel to itself such that the tail of B coincides with head of A. So the tail of B coincides with head of A. Now, there is a free tail. There is this free tail and free head left here, right? What we do is we join these two, tail, and we put a vector in between those. So, and we get this vector as vector C. I hope I'm making some sense to all of you. Yes or no? So this vector C is nothing but vector A plus vector B. Clear है बेटा सबको? All of you. This is how we add the vectors. So what we do is we move the vector, we keep one of the vectors as reference vector. We move the other vector parallel to itself such that the tail of the vector, in this case it was vector B, the tail of vector B coincided with head of vector A. The remaining tail and head is vector C, right? Similarly, the question now arises, is B plus A equal to A plus B? इसमें क्या करना है? What we will do here is we will fix vector B. So now we are keeping vector B as reference vector. Okay. And we move vector A parallel to itself such that the tail of vector B coincides with head of vector. Sorry, tail of vector A coincides with head of vector B. And now you can draw these two, you can draw a vector in between this. You guys can see that it is identical to what we have drawn. If you move this vector, it completely superposes on the other C vector, right? So it is the same vector. So here we say that the question is yes. The answer to this question is yes. A plus B is equal to vector B plus A. So we say that vector addition is commutative. I hope you understand what is commutative. A vector plus B vector is B vector plus A vector. Any doubts in this? Any challenges in this? Please ask.
Sir, so do we use Pythagorean theorem to find out C?
No, no, no. It's not, they are not at right angles. No? We will use different method to find it, but I have just given you an overview of how we add two vectors. I'll tell you other methods to do it, but not now. Okay.
Okay.
In this case, we can't do Pythagoras theorem because they are not at right angles. Right? Please note it quickly. I hope all of you are done with this. Okay. So let's move ahead to the next part of it. So we are now aware about addition of vectors, right? So then comes unit vector. So unit vectors, a vector which has magnitude 1 is a unit vector. A vector which has magnitude 1 is a unit vector, right? Now, magnitude is the measure of the vector. Okay. So the application of unit vectors is it is used to indicate the direction of a vector. ठीक है? Conventional unit vectors are conventional unit vectors are conventional unit vectors are I cap, j cap, and k cap along positive x, y, and z axis respectively. ठीक है. So conventional unit vectors are I cap, j cap, and k cap. This sign is called as caret sign. This sign is called as caret sign. ठीक है. But we call it as cap. Okay. Any vector which has this cap will be a unit vector. Right? So I'll just show you how we used it. So suppose I have this xy axis. This is, I'll draw all the axes in fact. Just a second. This is y axis and this one is z axis. Let's see. Okay. This is x axis. This is y axis and this is z axis. So I cap. A vector along x axis, a unit vector along x axis is I cap. This is I cap. A unit vector, magnitude of this vector is 1. A unit vector along y axis is j cap. A unit vector along z axis is k cap. So this is I, j, and k. Now, how do we use it to indicate the direction? Okay. So let's see how do we use it to indicate the direction. Just pay attention, all of you. Okay. So this is a man standing at the origin, right? He decides to move by 3 units in this direction. He decides to move by 3 units in this direction, right? This point is, let's say this point is point A. And this point is point O. This is 1, this is 2, this is 3 meters, right? So the new position of this man, or let's call the displacement of this man with respect to origin. So displacement of this man is equal to, what is magnitude of it? It's 3 units, right? 3 meters. Meter represents the physical quantity, right? Which physical quantity it is representing. So unit is representing the physical quantity. What is this physical quantity? Length. Yes or no? Right? In this case, length is representing displacement, right? So meter is representing the physical quantity. Which physical quantity it is? 3 is representing the magnitude of it, the measure of it. And direction is I cap. So if I say I cap, all of you understood that, okay, this man is moving along positive x-axis. I hope all of you understood this. Yes or no? Hello.
Yes, sir.
Okay. Now, if, let's take one more example. If this man takes a sharp left turn, a 90-degree left turn, right? And he moves by, say, 2 units. The man moves by 2 units in this direction. So let's say he reaches a point, which is point B. So this is 2 units. So if I ask you, what is position vector of B with respect to A? It will be 2 meters. Can I say it is 2 meters j cap? All of you, yes or no? Because he has moved by 2 units towards y-axis. So this is how we represent. So again, this indicates the physical quantity, which is position vector in this case, right? See, meter can represent multiple things. This is representing the magnitude of it or the measure of the vector. And J is representing the direction of it. I hope I'm making some sense to all of you. Yes or no?
So
Okay, good. So please make notes quickly. हाँ भाई, understood or not? आप noted?
Yes,
Please
sir.
type done when you are done, when you have noted it, okay? Good. Thank you, Aaron. Ritesh and Harshita. Done? Okay. So now we know unit vector, we know addition, how do we add vectors, we know position vector, magnitude of a vector, right? Representation of a vector. Now let's try to learn about resolving a vector into its components. This is very important, so please pay attention. Resolving a vector into its components. I'm not, I'm purposely not writing breaking of vector into its components because in some of the books it is written like that, breaking a vector into its components. We don't break, we resolve, right? Now, what do I mean by resolving a vector? All of you have your pen with you, right? So what you do is just disassemble your pen. Tell me how many parts of your pen, how many parts your pen is made up of. You can disassemble your pen into different components or not. If you can, please let me know how many components. 3, 4. Quickly. 4. Okay, Haran. Ritesh, how many components?
4, sir.
Obviously 3 or 4, right? Now, can you guys reassemble it again and make the pen again? कर सकते हैं? So, this is the beauty of resolving a vector. This is what is resolving, right, into its components. So we are dissembling it, we are assembling it, right? So here also we resolve a vector into its components. We are talking about planar vectors, right? So a planar vector can be resolved along any two and coaxial, sorry, and coplanar lines. A planar vector can be resolved along any two mutually perpendicular and coplanar lines. Now, you can read it 2, 3 times and I'll show you what do I mean by this. So if this is a vector, first of all, tell me, just write it in the chat window, how many coplanar lines can I draw? Parallel pair of coplanar lines can I draw? Coplanar, perpendicular lines can I draw on this plane? How many numbers? I hope I'm clear in my question. How many mutually perpendicular how many mutually perpendicular coplanar lines can I draw? Pair of coplanar lines can I draw on this plane? The plane of your screen. Give me the answer. Write in the chat window or you can switch on your mic and tell. Okay, so it's infinite. Very good. So I can show you, you can draw infinite lines here. Infinite pair of such pair of coplanar lines, right? This is one of it. This is another one. So this way you can draw infinite number of lines, right? Now, I have a vector like this. I have this vector with me. And I want to resolve this vector into its components along these two mutually perpendicular lines. This is x-axis. This is y-axis. So all of you can see here that this vector R is coplanar with vector x, sorry, lines, the plane xy, right? Now, the vector is making an angle theta with the horizontal line and positive x-axis measured in anti-clockwise sense. So this angle is theta. So now how to find the component of this vector along x-axis? So this is tail, this is head. What you do is you drop perpendiculars from head, from tail, and from head on the x-axis. Okay. So you are drawing perpendiculars from tail and from head on the x-axis. You can take them as shadows also. So this is the shadow of vector r along x-axis. The shadow of head, tail will be a tail, the shadow of head will be head. So this is vector r x. This is the magnitude of it is rx I cap. Can I write it like this? It is pointing along positive x-axis and its magnitude is rx. All of you, just say yes or no.
Yes, sir.
Similarly, the magnitude of this, sorry, the component of it on y-axis will be, just draw the perpendiculars along this from tail and head. And this is the shadow of the vector on or along y-axis. So this is ry vector, which is also can be written as ryj cap, right? So now, as you have done the exercise, what you did was you assembled the pen again, right? This was dissembling. So if these are legit components of vector r, when they are added again, we get vector r. So I'm just see this. I'm moving this vector rx parallel to itself such that it reaches this location. Similarly, I move this vector ry parallel to itself such that when it is added to vector rx, it is giving me vector r. So we can say that these are correct, these are true resolutions of vector r. I hope you understood this. Hello.
Yes, sir.
So we have this vector, we have this right angle triangle. This is vector, this is r, this is ry, this is rx, and this angle is theta. So rx, ry, and theta. Now, can you guys see here? This is a right angle triangle. We know r, we know these values, right? We know r, we know theta. We have to find, please mute yourself if there is some background noise. So this is rx and this is ry. We have to find these values in terms of r and theta. So how do we do that? We will write sine theta. Sine theta can be written as ry upon r. So ry is r sine theta. What about cos theta? Cos theta is rx over r and rx is r cos theta, right? So now we know the components in terms of the magnitude and direction. So ry is r sine theta and rx is r cos theta. So can I write ry as r sine theta j cap and rx as r cos theta I cap? ठीक है? I hope all of you understood this. Yes or no?
Yes.
You can find how to find. Now you understood how to resolve a vector into its components. Any doubts in this case?
No.
Okay. Please write it quickly. Make notes. Noted, all of you? Chalo, shabash. So now a planar vector can be resolved along any two mutually perpendicular and coplanar lines. This is what you need to remember, right? Now, the question is, if a vector is shown as a sum of its components, so if a vector R is shown as a sum of its components, let's say AI cap plus BJ, right? Can we find magnitude of this vector and its direction? And its direction. So how do we do this? So what you do is simply, first of all, make an XY plane here. Please pay attention, huh, all of you. Now, since you know how to add two vectors, first you draw the X component, that is AI cap. This is AI cap. And then you draw the Y component, which is BJ cap in this case. Okay. Now you know what is the resultant vector. This is the resultant vector, vector R. I hope all of you understood this. Yes or no? AI cap plus BJ cap. This is how we are adding these two vectors. Now, since it's a right angled triangle, so we have, this is B, this is A, this is R. So using Pythagoras, it is A square plus B square ka root, right? So, or you can generalize it as root of, what is A here? A is coefficient of X component, the square of coefficient of X component plus the square of coefficient of Y component. Okay. The root of this gives us the magnitude of vector R. Clear hai ye? All of you, yes or no?
Yes.
And this angle theta, the direction of it is tan theta, is equal to B upon A. This is what? This is coefficient of Y component, and this is coefficient of X component, right? Or theta is tan inverse of B over A. I hope all of you understood this. Yes or no?
Yes.
So this is the generalized format to find the coefficient, the magnitude and direction of a given vector. Now always remember, this angle theta, the angle theta which we are measuring like this, okay, is always measured from the positive x-axis in the anti-clockwise sense. See, clockwise and anti-clockwise are not directions, they are sense of rotation. So whenever a vector is written in the format of its x and y component, whenever a vector is shown as a sum of its x and y component, you find its magnitude and direction like this. And the direction is always measured from positive x-axis in anti-clockwise sense. I'll show you one example. So if I have a vector like this, vector R1, which is 3 minus I cap plus 4j cap. Please pay attention. So to make it the coefficient, how do we write the coefficient? The sign should be with the constant. I cap is with this plus 4j cap. I hope all of you understood this. Yes or no?
Yes.
Yes.
Now, so the coefficients are made like this. Okay. Now you draw it here. It's 3 minus I cap plus 4j cap, right? This is 3 minus I cap plus 4j cap, and the final vector is this vector. Okay. This is vector R1. Now pay attention. Magnitude of vector R1 is nothing but root of minus 3 chi square plus 4 chi square. Okay. So this is 5. I hope all of you understood this. Yes or no?
Yes.
The angle is always measured from positive x-axis in anti-clockwise sense. So tan phi is equal to 4 upon minus 3, or phi is tan inverse of minus 4 by 3. Clear? Say yes or no.
Yes, sir.
So this is how we measure the angle. This is how we represent the angle. Okay. If you have any doubts, please ask. So when a vector is given in this format, when a vector is given in as a sum of its components, this is how we find its x and this is how we find its magnitude and direction. क्लियर है भाई सबको? हाँ ना बोलिए सब.
Yes, sir, clear.
Okay. So just make notes. Harshita, I didn't get your question. Do we use same formula to find both magnitude and direction? I'm unable to understand. See, obviously, when a vector is given in this format, you will use the same formula for all the vectors which are shown as a sum of its x and y components. I'm talking about planar vectors only. If the vector is in yz plane, it will be there. It will be shown as a sum of its y and z component, right? All of you noted it? Okay. So So this is all for today's session. The book which we will be following is Concepts of Physics, H.C. Verma. How many of you have that book with you? Or you want me to send you the sheets? Choice is yours.
Can you please send the sheets?
Okay. I'll send the sheet in the group, right? I'll mention the homework also. I'll show you the homework so that you can actually. This is the booklet, right? For basic maths only. And there is a chapter, the chapter is vectors. You are all aware of it now. So this is the chapter. Just read the chapter, okay? As much as you can read it, okay? And start solving exercise 1. Exercise 1 is in page number 62, I think. Yes. This is exercise 1. And simply you have to solve question number 1, 2, 3, 4, 5. नहीं, 1, 2, 3, 4. अभी इतना ही करो. Actually क्या है? One more class is required for till you understand triangle of addition of vectors. I'll send this to you. So next class, I'll give you some significant amount of homework, right? So thank you so much. This was the end of the session. Thank you so much. This is vector session 1, right? Thank you so much.